Hi everyone. In today's session we're going to speak about two new tools that were introduced by IAB Tech Lab in order to improve the marketplace transparency. The topic which was very important for all the players in the supply chain, starting from the publishers, then the exchanges and the sellers, everybody who is involved into programmatic trading, ending up with the buy-side platforms and of course the advertisers behind them. Well, first of all, let's take a look at the list of issues that currently the programmatic ecosystem is facing. Domain spoofing has been always this kind of fraud, shaking the industry, and since the introduction of ads.tech solution by IAB around 2.5 years ago, we see actually tremendous improvement towards a better marketplace transparency. A lot of networks that have been doing some shady business and trying to make the inventory that they sell look much prettier to the buy side, they're now eliminated from the marketplace, and some of them had to change their business, and some of them really going not through the best times. Though the problem of domain spoofing is not really solved for the moment and looks much better for the web, but mobile apps and connected TV are still going through the adoption period of app ads.txt, and of course we're waiting for much better results in 2020. And the advertisers these days, they stop just asking a question, where are my ads being shown? But they also want to know who are these intermediaries that are involved into each transaction, starting from the ad request from the publisher side, ending up with a bid by demand side platform that these advertisers are using. They also want to know which entities are being paid for each transaction. They want to know who applies the fees. They want to know who keeps the margins. And the idea of removal of value extracting intermediaries became one of the latest trends of the industry. And it doesn't mean that resellers will eventually be fully cut off from the OpenRTB. They still bring unique value, unique formats, probably some data. And of course, although the big demand side platforms started questioning if this openness of the ecosystem, which was one of the goals to connect all the demand side partners, all the demand side platforms with supply side, and give opportunities to bid everyone for everything. But now they really came to a conclusion that some action is really required from their side and from the side of every intermediary and every seller in this process, because the brands and advertisers are ready to take transparency control into their hands. They want to be as close to the source as possible. And of course, they want to have the opportunity to identify and to use the exclusive supply chains. And IB, greatly inspired by the success of ads.txt project, came up with two new solutions. It's ads.cert and adcom that are parts of the OpenRTB 3.0 protocol. And these are really interesting ideas, which would mean the big shift towards the better understanding of the supply chain from the buy side. But unfortunately, we all know how long the adoption process of ads.txt took from the publisher side. And the implementation of ads.cert is much more sophisticated because it requires publishers to work with encryption providers. And secondly, the OpenRTB 3.0 protocol. It's currently not widely used in the industry. It will definitely take the advertisement systems some time for the implementation, at least simply because it's not backwards compatible with the previous versions of OpenRTB. And in April 2019, IAB Tech Lab posts the draft version of two new tools called sellers.json and the supply chain object, which can be used with the previous versions of OpenRTB 2.3 and 2.5. And first of all, these two tools are made to be complementary solutions to ads.txt. They're like three brothers that cannot live without each other. And before we dive deeper into trying to understand how exactly these two new features work, let's just summarize what are the issues that they're going to solve. Although the programmatic ecosystem is evolving in a natural way and the technology is going through the changes which are necessary in order to resolve the vulnerabilities that were created and exposed by the advertising networks. They were exploiting the openness of RTB itself. The necessary changes were of course driven by the needs of the advertisers, represented by their demand-side platforms. And as I said, they're willing to obtain the full control around the transparency and understand about each and every vendor and ad platform involved into the transaction process for impression. They're willing to allocate more budgets into in-app and connected TV inventory safely. And thanks to AppAds.txt, this seems to start working now. Another important thing is that these days publishers tend to work simultaneously with multiple supply-side platforms, different exchanges, and they're trying to implement various header bidding wrappers that allows them to initiate as many auctions as possible for a single impression, access as much demand as they can, which makes sense because they're trying to generate more revenues. But on the demand side, the picture looks absolutely different. DSPs keep receiving more and more bid requests that are actually encouraging them to participate in one single auction, encouraging them to bid against themselves for one single impression. And of course, they don't like this scenario. They would want to meet their objectives with fewer vendors. They would like to bring more value to their advertisers and to the publishers at the same time. And a fourth goal is actually combining the previous ones, assuming that the DSPs get the control around transparency that they wanted. They do see the supply path and every entity in the transaction. Then this is a ton of data, a lot of information that demand side has to make use of. This is called data-driven supply path optimization. This is something really new, and big DSPs already started working on these products. So how are these two new tools, sellers.json and supply chain object, are going to help the industry? Let's take a look at the scenario where they're not in place. Let's assume there is a supply-side platform which is called Direct Seller. They are working with Warner Media LLC, a big trusted publishing house, and the ad request is coming from website cnn.com, owned and operated by Warner Media, straight to the direct seller. There's another website which is called freetorrent.com, and it is operated by Media for All. And the request from this website is coming through the ad network, which is spoofing a domain and passing it to a direct seller as a request which is coming from cnn.com. And there is another player in this chain. Let's call it a reseller. Both requests received from cnn.com and freetorrent.com are passed by the direct seller to reseller. They don't know that the second request was spoofed by the ad network, and to reseller they look the same, only with the difference that the publisher ID is different. In first case it's 3579, and second case is 4123, which is associated by the direct seller with the ad network that they work with. And finally, there is a buyer, a demand-side platform that receives the bid requests from the reseller. And they also look the same. They're coming from cnn.com, and the only difference is this publisher ID, which is on the reseller side are associated with the direct seller, the entity that they work with. What would the buy-side platform do in order to validate if the reseller is actually legit to sell the inventory from cnn.com? They're gonna go and find the ads.txt file on cnn.com, and what they're probably gonna find is the string which is mentioning reseller.com as authorized seller of the inventory from CNN. 1234 ABCD, that's the only possible ID that could be found there, because CNN doesn't work with ad network but works with a direct seller. In this case, on the buyer side, the first bid request that they received would look absolutely legit. But the second one, which originates from freetorrent.com website, would probably be rejected, because 2345 BCDE publisher ID was never found on the ads.txt file at cnn.com. Great job by everyone in the supply chain, except for the shady ad network, whose fraud didn't go through because of the ads.txt file. But the things don't always go so well. There is another possible scenario where a reseller on its side associates the same publisher ID with all the requests coming from a direct seller, because this is the entity they have relationship with. The DSP would crawl the ads.txt file at cnn.com like they did before, and they would find the same string mentioning reseller and the publisher ID 1234 ABCD. In this case, both bid requests received by the buyer would seem legit, and ads.txt didn't really help here. Having sellers.json and supply chain object provided with these requests would actually do the job. Let's finally take a closer look at each of these tools. Sellers.json is a publicly accessible file hosted on the business domain of the advertising system. Its content is a mapping of all the publisher IDs that the advertising system is sending downstream to its buyers, with actual legal entities that stand behind them on the supply side. But how are these entities actually connected with the information provided within the bid request and the information from the ads.txt files? This is the sample bid request sent, let's say, from the AdExchange1 to AdExchange2, and the important part of this request is actually the site object, which contains the page where the initial ad request is coming from, contains the domain that should be scanned for the ads.txt file, and the publisher ID. The case for in-app is a bit more complex, but very similar to this one. The buy-side platform would scan the ads.txt file at website1.com and look for this publisher ID 3579. If the AdExchange1 has correctly implemented sellers.json file on their domain, then the buy-side platform would get an opportunity to scan this file as well. It would look for 3579, which is matching the publisher ID and the string that they found in the ads.txt file. And now the buy-side platform can really see what is the exact name of the publisher or the other entity that the Exchange1 is working with. In this case, Exchange1 was the only ad platform involved in the supply chain before the request came to the buyer. The DSP could identify that 3579 stands for the publisher with the name Publisher1 Limited. This is just one seller object, probably in a big list of sellers implemented on the domain of that advertisement system. Let's check the full structure of sellers.json file. The parent object, first of all, consists of 4 fields: contact address, which is the business address of the advertising system; contact email, that the buyers can use to contact the advertising system on any questions or inquiries about this file; then the version of the declaration of sellers.json file, and the only available value so far is 1.0. It's very interesting that actually 25-30% of different ad exchanges with sellers.json files implemented that I've actually took a look at had listed this attributes value not as a string as it's recommended by IAB Tech Lab, as it's fully according to their specs, but as a number, which is apparently incorrect. Also, version is the only attribute in the parent object which is required. The last one from these 4 fields is identifiers attribute. Actually, it's an array of objects, and here the advertising system can list its trustworthy accountability group ID or Dun & Bradstreet business identifier. This is how most commonly sellers.json files parent object looks at most of the websites of the advertisement systems. Finally, we get to the array of sellers represented by the ad exchange. There's 7 main attributes: seller ID, name, domain of the entity represented by ad exchange, then directness, which has been changed to the seller type attribute with the latest version of the sellers.json specs. Then is confidential attribute, which is I'm going to focus on it a bit later. Then the placeholders for the comments and the extension object. And the last one, which was introduced only with the final version, is pass through. So from all these attributes within the seller object, only seller ID and seller type are required, although if the isConfidential flag is set to be 0, then the name and the domain of the entity should be listed as well. From these examples, only the first object actually contains all the attributes. Second and third are looking pretty much how they're usually listed on the domains of the advertising systems. Object number 1 shows that there's direct relationship between the ad exchange and the entity mentioned in this object. Object number 2 shows that the ad exchange is acting as an intermediary platform. In other words, doesn't pay directly to this entity. And the third example indicates both, means that both types of inventory are transacted by the seller. A bit more in details. So when the advertisement platform is choosing what to put to the seller type of each object, they need to answer 2 simple questions. The first one, does this ad system pay the named entity directly for the inventory or not? If no, then it should be mentioned as intermediary. If yes, then goes another question. Does the named entity own the site's or app's inventory? If no, again, intermediary. If yes, then it should be mentioned as publisher. If the combination of yes and no answers applies, then both should be selected. So in case the publisher is the value of the seller type, then it's actually connected to the record in the ads.txt file operated by the inventory owner, where the ad system should be listed as direct. Same for intermediary, it should be listed as reseller. And as you might guess, if the both value was set in the sellers.json file in the seller type, there must be more than one record in the ads.txt file where the ad system is listed first as a direct seller and second as reseller. And isPassthrough attribute is, I think, the last one that requires a bit of clarification. That's integer. It's the optional attribute with a default value of 0, could be also equals to 1. A pass-through seller is a facilitator of inventory from the upstream supplier to the consumer. The upstream supplier and consumer, they must establish a business relationship with each other such that the upstream supplier has control of their account within the consumer's platform, which actually leads to asking a question. Is the system that receives the bid request required to hold the contract directly with this entity? If no, then its pass-through should be set to 0. If yes, then set to 1. There are currently only 3 examples, I guess, of the pass-through systems. So far, it's Google Exchange Bidding, Amazon TAM, and BidSwitch. A few words about the setup of the sellers.json file on the server of the system. So the DSPs should consume the content of the sellers.json declaration on a regular basis. It is recommended by IEB that the expiry period should be 7 days. So every 7 days at least, the DSP should scan for the new results from the sellers.json file. The declaration can be both accessible via HTTP or the secure connection. Secure connection always has a priority in case the results somehow differ. And if the server responds with the 200 success status code, the advertising system must read the content, parse it, and utilize the data. If the server responds with a redirect, which is 301, 302, status code 307, then the advertising system should actually follow this redirect. Multiple redirects are allowed within the original domain, and only one redirect out of it is allowed. Of course, the consumer systems, the buy-side platforms, would run their crawlers and then cache the results or store them somewhere, which means it's essential to do the setup for conditional requests on the side of the advertisement system. After checking a lot of the implementations across the industry on different websites of various ad exchanges, looks like setting up the 2 essential response headers, last modified and e-tag, is quite enough to comply with all the possible crawlers run by DSPs. The last modified header returns the time of the last update of the file and e tag is the hashed version of some content. So in case the DSP has already accessed the data from the sellers.json file and it knows the last time it did it, it can set the header in the request, set the if modified since header and if non-match, and provide the e tag and the date of last modified that it received last time. Then in case of no changes, the server could respond with just 304 not modified, and no actions would be required on the DSP side to update the data that they already possess. If the file was modified, then the server would return 200 OK, new last modified time, and new e tag, of course, along with the modified content. Now we're jumping to the supply chain object, which is the best companion of sellers.json. It's basically the extension of the OpenRTB bid request, which is composed of the set of nodes, where each node represents a specific entity that participates in the transaction for the inventory. The chain of nodes from the beginning to the end represents all the entities who are involved in the flow of the payment for inventory. Let's take a look at the simple bid request. What changes when the supply chain object is being added? We can see that it is located within the extension object of the source object of the bid request. It contains a few root attributes, but the nodes array actually right here represents only one entity, which is exchange1.com. But what we can see that the seller ID 3579 is matching the ID of the publisher that was provided in the site object or app object of the bid request. And our ID within the node is actually matching the ID of the bid request itself. Taking a closer look at the attributes of the parent object, the first one is complete, which is a flag that indicates whether the supply chain contains all the nodes involved in the transaction, leading back to the owner of the website or application, where 0 equals no, 1 equals yes. Then the version of the supply chain specification, currently only 1.0 is also available. The extension placeholder for advertising specific needs. And we get to the important part, which is the nodes array. It consists of a few attributes. First one, ASI, as I understand, that's advertising system identifier. And here should be placed the domain of the advertising system which is sending the bid request. The pretty much same that we see in ads.txt files, and the same that the buy-side platform is addressing for checking the sellers.json. The second attribute was called PID initially, then it was renamed to SID, that stands for seller ID, and the latest version of supply chain object specs. These are the only two required attributes within the node. Then the RID is an optional string, which actually should be the copy of the bid request ID. The name and domain, pretty much same data that we saw in sellers.json file. This value is optional and should not be included in case it is in sellers.json. Then HP, the most mysterious attribute. It indicates whether this node is involved in the flow of payment for inventory. When it's set to 1, the advertising system in the ASI field, advertising system identifier, pays the seller in the SID field, who's responsible for paying the previous node in the chain, if it exists. When set to 0, this node is not involved in the flow of payment for the inventory. Important remark that for the version 1.0 of the supply chain, this property should always be set as 1. A simple flow of how actually the participants of the flow are adding the node objects. So the first seller in the transaction is supposed to create the supply chain object and set the complete attribute as 1 and add its node. In our case, it's a direct seller, adding the publisher ID 3579, adding the ID of the bid request that it generated and sent to the next system downstream. It added the name and the domain of the entity that they have relationship with, that they received the initial ad request from. And the reseller in this transaction is supposed to copy the node that it received and add the new node. If for some reason the supply chain was not provided in this bid request received by the reseller, then it should set complete attribute to 0, add its node, and pass further. Not all the time the communication between the platforms within the programmatic space is working through the OpenRTB protocol. Sometimes the reseller tags are implemented directly on the pages of publishers or have tag and tag integrations through different ad servers. So the serialization is the set of rules that is defining on how the supply chain is going to be passed through the tags. This is how, in general, the display and vast tags look. And in this case, the schain placeholder query string parameter is the one that passes the value of the supply chain. But how should this value look if in the OpenRTB protocol that's a complex object containing a lot of different attributes? So there is a defined format by IAB Tech Lab. It's supply chain object, then the exclamation mark, then the supply chain node array. The supply chain object lists version and complete attributes separated by comma, and the array of the supply chain node properties is also listing all the internal attributes separated by commas. Let's try to compose the value of the supply chain based on some example from the OpenRTB protocol. So here we go. We have two nodes, the direct seller and reseller that we already have seen in the previous example. Then the first part is going to look like version 1.0, comma, then the complete attribute, then the separator, which is exclamation mark, and then the first node goes. The advertising system identifier directseller.com, the publisher ID in this system 3579. Then goes the HP attribute, then the RID, then the publisher name, which is URL encoded, and publisher domain, publisher.de in this case. The last attribute in this node, which is the extension array, is empty. Therefore, there's just comma left in the end. And then goes the second node after another exclamation mark, which is a separator. We have reseller.com. The SID is ABS, long string. Then we have HP, which is set to 1. Bid request, number 2. And then 3 empty values that are, there's no name, no domain mentioned, and the extension array is also empty. This is how it all looks together. Supply chain object, node 1, node 2, looks quite readable. Then how is it all actually connected? We review the sellers.json, we review the supply chain, there's always a connection to ads.txt. Let's see what the DSPs can actually verify. How do they understand who is legit, who is not legit from all this amount of data that they can analyze? After receiving the supply chain object, DSP is capable, first of all, of checking the ads.txt file at the website.de that request is originating from. First of all, we would look for the publisher ID 3579, which would match the node number 1 of the supply chain object. Then we would look for the request ABS 776 blah blah that would match the node number 2 of the supply chain object. First one should be direct, the second record should be reseller. Great match. Then we're capable of checking the sellers.json file at directseller.com. Seller ID 3579, name publisher GmbH, which matches the node 1 from the supply chain object, domain is also matching, and the seller type is publisher. The last instance to check would be the sellers.json file at reseller.com. Again, looking for the seller ID, then checking the name, domain, and seller type. Node 1, all looks good, approved. Node 2, the same. In this case, all the needful information was provided to the DSP in order to have the full understanding of what was involved into the supply path for this transaction. Now let's get back to the very example that we had in the beginning of our session, when ads.txt file didn't really help the buy-side platform identify that the second bid request was coming from the seller which didn't have an authority to sell the CNN.com inventory. This time, the DSP has additional resources in order to understand the full supply chain. First of all, it can address the sellers.json file at reseller.com because this is where the demand-side platform got the request from. It's looking for 1234 ABCD seller ID and it finds the record, which is pointing at the direct seller LLC with the domain directseller.com, which is the supply side platform that our reseller got the request from. So far, both bid requests received from the reseller.com look legit. The next step could be checking the supply chain object received from the reseller. In case of the first bid request, the supply chain object and its first node would contain SID 3579, as we see on the diagram. In the second case, it would be 4123, like in the second bid request that was sent from direct seller to reseller. Still, both bid requests look fine. The next step could be checking the sellers.json file published by direct seller. Finally, we got to the point of revealing more entities. 3579 stands for Warner Media, and 4123 is assigned to Ad Network LLP. That was the first sign that for these two different bid requests, the supply path was also different. And the final thing to check is finally the ads.txt file of CNN.com once again, and look for these new IDs that were revealed, 3579 and 4123. And of course, after scanning the ads.txt once again, only 3579 would be found because only direct seller is authorized to sell the inventory of Warner Media from CNN.com. ID 4123, of course, was not found at CNN.com because Ad Network LLP was not authorized to sell it. So with all this new data, DSP managed to avoid the case of fraud against it. It managed to protect the interest of the advertiser and also identify the best path in order to buy the inventory from CNN.com. More consolidation is going to happen during 2020. More DSPs will start utilizing data provided by the new tools introduced by IAB. The tools that don't require much efforts from the ad exchange perspective in order to implement and maintain. The DSPs will be soon able to provide additional tools to their advertisers in order to choose the supply paths that they want. Well, we're looking forward to seeing how in 2020 these processes actually change and how they're going to establish themselves. Thanks everyone for watching, and if you have any questions, don't hesitate to drop us an email at info@yog.com. We'll try to answer you. Thank you and goodbye.